In this session, we're going to look at sequence. Okay, sequence. As you can see in this place, these are numbers. Each of these is called what? Sequence. This is the element of this sequence, another element of this sequence, another element of the sequence, another element of what? The sequence. Okay? So these elements are called terms. The terms of what? A sequence. What you will observe here, in each of the sequence, we have different patterns. Like the first one you can see on the board, this one, to get this, you need to add 2 to this. To get this, you need to add 2 to the previous term. To get this, you add 2 to the previous term. Okay? For this sequence, is different from this sequence. Because to get this, you need to subtract 3 from the previous term. The same thing. To get this, you subtract 3 from this. To get this, you subtract 3 from this. To have -1. This dot you are seeing here represent continuation. In case you want to continue, you can continue indefinitely. Okay? Now let's look at this sequence. For this sequence, to get this, you need to multiply this by 2. To get this, you multiply this by 2. To get this, you multiply this by 2. To get this, you multiply this by 2. For this, to get this, you divide this by 2. To get this, you divide this by 2. To get this, you divide it by 2, and so on and so forth. As you can see, there is something that is common among the terms of the sequence, where you are looking at what? Sequence. Now, let's continue. A sequence is a set of numbers which follow a definite order, and in which each consecutive member can be obtained from the members immediately before it, just as you have seen. So for this, for instance, as you can see, we have 3, 5, 7, and 9. To get this term, you need to what? To add 2 to this. That is 5. To have this, you add 2 to this. That is 7. You add 2 to this to have 9. To get the next one, you add 2 to this to have what? 11. To get the next one, you add 2 to this to have what? 30. And so on and so forth. Okay? So for this sequence now, we can what? Derive a formula for it. That formula is called the n-term formula. N-term. That is a formula that represents this sequence, which you can use to generate any term in the sequence. What we need to do, we are going to look at this first. This is the first term. We represent it like this, because this is what? N-term. So, because this is the first position, we'll say T1 is equals to 3. For the second position, which is second term, you agree with me to derive it, we derive it from the first term. So we are deriving it from this 3. How? By adding 2 to this. We are looking for the formula. For the third one, as you can see, this third one must come from here, which is this. So we have to write this down. What can we add to this to get 7? Another 2. Okay? For the fourth one, we need to write this down before we ask ourselves, what is that thing that we put here to get 9? That is 2. As you can see, there is a pattern of 2, 2, 2, 2, 2 be added to the previous term to get the following term. Therefore, because all of them have 2, 2, 2, 2, we have to also include 2 here to just to balance the arrangement. But the point is that once I add these two here now, I am not changing the value of 3 to 5. That is not logarithm mathematics. That is forgery. To destroy these two, I will multiply it by 0. What have I achieved? Just for me to see 2. I just want to see 2 here. That's what I've achieved. But by introducing multiply by 0, these other guys also need multiply by something. So I have to also say 2 multiply by what? The only way to retain these 2 is to say multiply by 1. All these other guys need the same thing. So I have to remove this now to say 2 multiply by 2. Remove this to say 2 multiply by 3. As you can see, we now have what? A pattern. Now to get the nth term now, we have to write whatever that is here, that is common among all of them. All this, you can see, plus is all here. I put plus. 2, common. Multiply, common. This one keep changing. Let's see if we can connect it to the term. If I say 1 minus 1, I will have 0. 2 minus 1, I will have 1. 3 minus 1, I will have 2. 4 minus 1, I will have 3. Therefore, I will say n minus 1. So, you agree with me, this is 2n minus 2, 3 minus 2 plus 2n. This is 1 plus 2n. This is the formula for what? For the nth term. With this now, I can get the 1001 term by saying 1001, 1 plus 2 multiplied by 1001, which is 1 plus 202. I have this 3. Okay? So, this is the value we found. If you continue to write this down till you get to 1001 position, this is the value you will get. For instance, this is the third term. If I take the nth term formula, it says this equals to 1 plus 2n. So the third term now is 2 multiplied by 3. 1 plus 6 equals to 7. So you can see, this is 3, third term. So as you can see, 7, which you just what? Obtained from the formula, which is n term.